A couple of months ago, I decided to try and calculate my personal carbon footprint, the amount of greenhouse gas that I produce in units of carbon dioxide. I Googled it and found some different formulas for how to do it. My personal footprint is determined by my daily lifestyle and activities, such as how I travel, what food I eat, what I buy, how I use electricity, and what source that electricity comes from. A lot of those things I simply don't know. Take my lunch today for a start. How far had the ingredients been transported before they became my meal? And were they transported by truck, by plane, by train? It didn't take long to realize getting an accurate answer for my personal footprint would take a lot more research. If measuring carbon emissions in your own personal life is a challenge, how much more difficult is it for businesses? Until 2001, we hadn't even agreed on a way to measure greenhouse gas emissions, let alone reduce them. The creation of the Greenhouse Gas Protocol then allowed companies to quantify and report their greenhouse gas emissions. It even came with a step-by-step guide on how to classify an organization's emissions into categories called scopes. In this episode, we examine how Scopes 1, 2, and 3 became an important global tool for reducing emissions and take a look at how the concept has been put into action in a very tangible way. With me in this episode to get a deeper understanding of how the GHG scopes can be a vital tool when it comes to reducing global emissions is Pankaj Bhatia, Director of the Greenhouse Gas Protocol. Welcome, Pankaj, to Shaping Sustainable Places.
Thank you, Madeline. Glad to be here.
Thank you. Now, what's the story, tell me please, behind calling the three categories for reporting greenhouse gas emissions scopes?
The concept of the three scopes comes from life cycle accounting methodology. It was an established practice to measure environmental footprint at the product level at the time GHG Protocol was launched. In the GHG Protocol, we wanted to include both direct emissions and indirect emissions so that companies can manage their impacts broadly, not just what are considered, traditionally speaking, emissions from their smokestacks, but also emissions that could be attributable to them from their upstream impacts and downstream impacts. So asking companies to also look at impacts beyond their factory boundaries was a very new idea. But there is another part, the fun part, the interesting part here is how did we come up with then the scopes to describe these three categories? At that time in about 2001, I think the period was 1998 to 2001 when we were working on the first edition of the GHG Protocol. BP, British Petroleum, was already undertaking a similar breakdown of their emissions in their internal emission trading scheme that they were running at that time. So they were using similar structure of direct and indirect impacts. And there was a BP technical working group member. So if I remember correctly, it was a recommendation from BP that we can use the terminology scopes to describe these three categories. So this is how we came up with Scope 1 for direct emissions, Scope 2 for energy indirect emissions, and Scope 3 for other indirect emissions. And the rest is a history.
And that takes us on to my next question, because I'd really like it if you could talk us through the differences between the scopes.
Scope 1 refers to direct emissions from a company's owned or controlled sources. Scope 2 refers to indirect emissions from the generation of energy purchased and consumed by a company. And Scope 3 are all other indirect emissions not included in Scope 2 that occur in the value chain of a reporting company. Scope 3 emissions are all other indirect emissions categorized into 15 mutually exclusive categories that distinguish upstream and downstream emissions.
Scope 3 accounts for the largest proportion of emissions by far, covering the entire supply chain, and then the lifetime energy-related emissions of a building, for example. If it isn't a strange question, why is the scope of Scope 3 so very wide?
It is very natural when you look at the corporate business in terms of how the companies manufacture a given product, let's say steel, for example. Then you have upstream activities that begin at a mining operation. You have so many different raw materials that are extracted during the mining, and then you have transportation of those materials, you have refining of those materials. So all these activities, they occur upstream. And then once the steel is produced, it is used in so many different products. So it is manufactured in a factory, and then it is transported to different users of the steel. And as you can imagine, in this modern economy, for example, there's so many different kinds of products that use steel in appliances, in vehicles, in other factory equipments. And so there is a wide variety of uses where a particular material is being employed. And when a steel company does its inventory for the downstream activities, our idea is that they will take into consideration also what are the impacts during the use phase, what are the impacts during the disposal phase of their products. And the idea is that in scope 3, it is capturing the life cycle accounting categories other than the direct emissions. So when you look at all the other life cycle activities that occur in the life cycle of a product, it is quite a lot. And steel is a very simple example, but you can get into some of the products that have even a lot more complex value chains or life cycle accounting. And so scope 3 has to capture all of them, and that's how its framework of upstream categories and downstream categories, which appear to be quite large, but they are quite aligned with the life cycle accounting, and they complete a life cycle accounting of a product or service that a company provides.
Now, from an overall perspective, how does calculating greenhouse gas emissions and reporting them through the 3 scopes help reduce global emissions?
I think the first principle is that you can't manage what you don't measure. So measurement or calculation is a very basic step for us to manage the impacts. Let's take an oil and gas company example. Emissions from their sold products typically comprise 90% of oil and gas companies' total emissions. So if they were only accounting for their scope 1 or even scope 2 impacts, they will likely miss 90% of their total emissions from a value chain perspective. These emissions will show up as scope 3 emissions. And oil and gas companies, they can influence and make progress towards decarbonization through their downstream emissions, through the design of their products, new offerings, or changing the way they meet consumers' energy needs. Further, calculating product use phase emissions need not be challenging. So assumptions about how products are typically used is a standard practice for product development. Large businesses, they have better tools, knowledge, and capabilities than their value chain partners, in many cases who tend to be small and medium enterprises. So having this value chain approach actually allows large companies to enable their value chain partners by providing them capacity support, engagement programs, and incentivizing an approach, because they have certain relationships. So they have the ability to incentivize their value chain partners to participate with them towards the decarbonization of value chains.
Pankaj, looking specifically at the construction and property development industry, can we talk about how the greenhouse gases are measured in the scopes there?
Very good question. So emissions calculations in the construction industry can be complex and will depend on a particular company's organizational structure, as well as which parties are responsible for the various purchasing decisions made during the construction activity in itself. A construction firm may end up reporting emissions in scope 1, 2, and a majority of scope 3. Emissions on a construction site will mainly consist of fuel burned on-site to operate heavy machinery, electricity used to provide lighting, operate fans and pumps, and charge smaller construction equipment. These emissions will be the scope 1 and scope 2 emissions for the construction firm. And like this, I think as companies begin to map out their scale of activities, their range of activities, and their partners, value chain partners, they will begin to understand what are some very important categories for them. And one of the most important category is the embodied emissions associated with building materials and used to construct buildings, including materials like concrete, lumber, steel, drywall, and various interior finishes. These materials will generally be accounted for by the general contractor in their Scope 3 Category 1 emissions, purchased goods and services. Then there is transportation of materials to the construction site. And then once the project has been finished or building has been finished, then emissions are reported in several additional categories of Scope 3, depending on who is managing the building, who is using the building. And then finally, when the building serves its purpose, life cycle is completed. And if there is a demolition, then also the projected lifetime emissions of the building materials as well as emissions from eventual demolition and waste disposal in Scope 3, Category 12, and the life treatment of sold products will also be important for the construction industry.
Now, Pankaj, finally, could you give us any type of prediction regarding the position and development of the greenhouse gas protocol, say 10 to 15 years from now?
I would say that based on 20 plus years experience, the time has been a great test of the GHG Protocol standards, and they have stood well. They have been not only used, but they have been adopted worldwide by thousands of companies, and now likely US Securities Exchange Commission will adopt it. They have already released a draft rule in the US, and they may finalize it, and it is based on GHG Protocol. California Air Resources Board is also expected to use it. In Europe also, there is an effort to use it. So one direction that in response to your question, I would say in 10 to 15 years is that we will see that the GHG Protocol reporting becomes standardized through regulatory frameworks and regulatory requirements all over the world. We see that happening in other countries also. Second, we will see that the GHG Protocol standards are being adopted and integrated into the financial accounting standard providers. So those who provide standards for financial accounting, which is, I think right now, IFRS is the global standard setting body for financial accounting standards. And their sister body, ISSB, has already adopted the GHG Protocol. And I think we will likely see that even further convergence and adoption into that. I think there is also going to be even greater progress on target setting. More and more companies will start setting targets based on the GHG Protocol standards in the next 10 to 15 years. I'm hoping, this is my final, I think, hope in this, that Scope 3 is reporting becomes even more effective as data becomes available, the primary data, and the practices take root in major economies, countries where they are not yet at the same scale as we see in US and Europe. So like in India, China, Indonesia, Brazil, and like that, other countries. And it truly becomes a global standard, not just in terms of the North, but also in the South.
Pankaj Bhatia, thank you so much.
Thank you so much.
If you want to find out more about the scopes and the greenhouse gas protocol, you can find an article on foresight.skanska.com. Now we move from scopes to action and to a story about how your way of thinking and working can change dramatically when your ambition is to reduce Scope 3 emissions from complex construction projects.
There have only been a few examples all over the world of this kind of reuse of heavy materials.
When building a new office building in Karlskrona, Sweden, the Skanska construction team transported 300 square meters of used concrete superstructure from another building in another city, which another construction company was knocking down. In this way, they could reuse components of the superstructure and reduce emissions. Welcome to Shaping Sustainable Places. Sustainability Manager Hus Syd, Anders Edvardsson, and Ivan Kusini, who is Sustainability Specialist, also from Skanska. What was the biggest challenge of transporting 300 square meters of used concrete superstructure from one building in one city to another building in another city? Anders, what do you say?
Well, there's a lot of challenges. How do you transport 300 square meters of hollow core slabs without taking any risks? We don't want to load and unload many times because that creates a risk for the material and for the people who work with them as well. And of course, there's a lack of standards. How do you do this? We didn't know. So we worked it out together. We kind of built our own standard for this particular building as well. And I can describe it in some way. We didn't know what would happen with the building when we started deconstructing it. So our first step together with a deconstructor, Daco, was to stamp the whole building so we could be sure that it doesn't fall apart when we start deconstructing it. This was a kind of a once-in-a-lifetime opportunity as well. The building is only 35 years old that was being demolished in Lund. And it's not often, and that's a good thing, I would say, as well, that we don't demolish 35-year-old buildings all the time. We wanted to test the material, so we sent the hollow core slabs, drill tests from them to a third-party research facility that checked the material, and they had a very, very long lifetime still left in them. And the deconstructor actually said that when they started sawing in the hollow concrete slabs, there was like a shotgun, an enormous sound from the building when we started to take it apart. So that's a really important lesson as well, that we don't build for deconstruction. It was not supposed to be deconstructed. It's possible, of course, but it's a big challenge because it's meant to stand there for 100 years.
And as to the actual transportation of it, Ivan, what would you like to add with regards to sustainability aspects?
Well, of course, transporting such heavy material from Lund to the final project destination, which was Karlskrona, something around 250 kilometers away, was a challenge as well. Depending on what kind of transportation tool you use, you have a different kind of climate carbon dioxide release. So we look at what it became, the solution. We found lorries that could drive in with biogas, diminishing by an astonishing mean the carbon dioxide release from one place to another. So the slabs have theoretically a zero embodied carbon from our project. And we also have a very, very low carbon intensity connected to the transportation of the materials to the final destination.
What would you say was the central motivation behind this decision? Was it to reduce costs, or was the aim to reduce emissions and environmental impact right from the start?
Well, it's an easy answer in one way, that reducing cost is not the question at all. It's actually increasing cost. It's quite complicated to deconstruct an existing building, and it costs more money than buying new hollow core slabs, unfortunately. So for us, it was partly, of course, to reduce climate impact. We have kind of strict goals for the new building that we wanted to achieve, and the second goal for this is as well, second motivation is, of course, doing something new. Like pulling the market forward, pushing limits on how we reduce climate impact. So we wanted to reduce our climate impact in the new building and also push the limits on what materials we can reuse. And maybe in some way try something new that we can do more times and do it more cost efficient further on as well.
Ivan and Anders, you've worked very closely together in this project. Have you agreed all along?
I think so. We almost always agree. And I think it's a combination as well. I'm not a concrete expert, and I think that helps in a project like this. You have to be a bit naive to actually be able to pull through a complicated project like this. But what do you say, Ivan?
It has been very easy to get along. If you remember, you asked me about this project while we were working in something else, and out of the blue you asked me if I wanted to have 10,000 square meters of reused hollow core, and I just thought about it for a second and I said, yes, what height? 270 millimeters. Yes, I'll go for them. And then we had, this is how we work every day at work. Of course, we work with every aspect of sustainability, and there wasn't a challenge there. We just look at the plan. We spoke with the project developer at Skanska that didn't even know that this was even possible. He got very interested about it. That's one of the keys of the success of this project, to have a project manager like Anders Liljefors that has been very inspiring and very much focused on sustainability and made this possible. And last but definitely not least, we even involved our customer, Vaxe Real Estate, and we spoke about this opportunity. And since they also had a very high, ambitious sustainability agenda, it was very smooth to work together to make this happen.
And speaking specifically about numbers, have you been able to assess the impact of this project in terms of carbon emissions and costs in general?
It's quite expensive, and it is like that the first time you do something new. It's always expensive, but I don't like to talk about it in terms of being expensive, because I think in some way when you talk about climate and pushing the limits, that I don't think reused hollow core slabs are expensive. I think the new ones that we buy from the factory is too cheap. In the future, when we have more and more tough climate goals, we have to do things like this as well. It has to be common practice in the future. So I think it could be expensive the first time you do something, because you do it safely, you try it the first time, and you develop new methods of doing it. But now we know how to do it. And regarding climate impact, yeah, it's an investment in knowledge, I would say, and also an investment in teamwork, because now all the key players know how to do it together as well. And I think, Ivan, you did some calculations on the climate impacts that we saved.
Yes, if I recall it correctly, we have saved about 30 tons of carbon dioxide just with this 300 square meters. Of course, we would have liked to embrace all the 10,000 square meters that were available, but since it was like a test pilot project, and it had a substantial higher cost than the standard, we agreed on developing these 350 square meters on the very top of this building, and 30 tons of carbon dioxide were saved.
So guys, I'd like to ask you what the most important lessons learned from this project has been for you personally, for you professionally, and for the industry in its entirety.
Well, I would say that the possibilities we have nowadays are incredible, but they are also incredibly challenging. The secret to make these things happen is a very committed team of very expert and capable professionals that are involved, to have a clear goal, to have clear legislation that promotes what we are doing, and a very strong focus on sustainability, and to make it as economical, sustainable as possible.
Yeah, my reflection is that the market is incredibly interested in these kind of things that we do as well. I think I get 5 to 10 phone calls a week on just this project. And everybody wants to know, how did you do this? How was the process in all this? And I think we learned a lot. And very, very important thing is that the core team in this whole project is happy to share the information as well, because we need to share this with our colleagues, our competitors, because climate is a global challenge. It's not for only us at Skanska as a company. We have to share this knowledge and work together, because one person cannot do this alone. We at Skanska cannot do this alone. We need all the team involved as well. So I learned a lot about cooperation as well, and how to produce a new business model for reusing materials, because that's a challenge as well. And I think we will see more of it in the future. And I think also that the value of these reused materials will just continue to get higher and higher when we get tougher and tougher climate goals. So we need to do this. And it can be a really good business model to work with reused materials as well.
Anders Edvardsson and Ivan Kusini, thank you so much for being on the podcast.
Thank you so much.
Tack.
In this episode, we talked to Pankaj Bhatia, director of the Greenhouse Gas Protocol, who explained the difference Scopes 1, 2, and 3 have made for reducing global emissions. Pankaj also said that he thinks the Greenhouse Gas Protocol standards will play an even bigger role in the future, and that the protocol reporting will become standardized through regulatory frameworks and requirements all over the world. And Sustainability Manager Hus Syd, Anders Edvardsson, and Sustainability Specialist Ivan Kusini, both from Skanska, told us about their pioneering project where they transported and reused 300 square meters of an old concrete superstructure in order to reduce emissions. If you enjoyed this episode, make sure to subscribe so you don't miss out in the future. If you have any thoughts about this episode or ideas for new ones to come, don't hesitate to reach out to podcast@skanska.com. We'd love to hear from you. This is a podcast from Skanska, a leading property development and construction group. To find out more about how we and others are creating healthy, resilient communities and spaces, visit us at foresight.skanska.com. I'm Madeline Joseph-Ricci. Thank you for joining us as we explore shaping sustainable places.